Welcome to this tutorial about how to test the application that we've built for the IIP-Ecosphere platform. This is the fifth step in our process to actually deploying a running platform with our services. We have two main parts here: creating unit tests and using them, and using generator tests that are provided on the generation of our templates. Some prerequisites. In this video you should have an installed platform and its dependencies, an installed IDE for the IIP-Ecosphere platform, which is a provided Eclipse from us. Both are taken care of if you're using the development container. If you don't really care for color coding for files non-Java in your workspace, then you don't even need the Eclipse provided by us, but it makes the development harder. You should know how to configure data types, how to configure services, and how to configure the application, as well as how to build the application, because that is, at least for some testing, a prerequisite. Other testing will be done before, but we wanted to keep testing together, so all testing is in this tutorial. Optional, you could have looked at the introduction to code generation if you're interested in stuff like that. So in the introduction, we have multiple levels of our testing. The first level is the service level. This happens before building the application. So as building takes some time, you might want to get done with this before finishing your building process or starting it even. Those are isolated services or method tests for their functionality, isolated from any connectivity into the platform architecture. This can be unit testing. You can also do this by just creating main methods, calling the methods of your services to confirm the functionality. Unit testing has an advantage as it's integrated into our build process and they will be run automatically. The second level is the services integrated. So this is, we test service by service, but mocked connectors for input and or output to test if it would also run in the context of the platform using artificial data created from the user to make sure that these services also do what they're supposed to do when they're inside their correct environment. Lastly, we have the app test, which tests the whole application on a simulated platform deployment. And if everything of this is running through, your platform deployment itself should be fine and should run without issues. Let's go over what's actually generated for the testing. First, for the unit tests, we have generated templates that reduce the work of implementing the test code. The structure of the test is already prepared, so you don't need to deal with the, for example, before and after conditions of testing. This is given in these files. Further, you have generated tests. This would be the next level, where you have the application with connectors, and you have the generated template files. As you probably noticed, you don't see the generated tests for the connectors in here. They cannot be seen in this project. They don't appear in this project as they are not meant to be edited anyways. What's needed is the generated test data templates. In this image we can see the two prepared templates as well as two freshly generated ones. So the json.temple files are the ones you will see when firstly generating these tests. And you need to remove the template to make them actually workable, as well as edit them inside. We will get to how to edit the inside of the file at a later point. These are used for the Python unit tests as well as the generated tests. The generated test data always has the pattern of test data minus service name.json.temple, so you will need to edit these accordingly. Here is the example of what's inside of such a file. You need to remove all the text at the top after reading it, as it will help to explain the file, and then edit the values. So you would need to edit the ends, as those are supposed to be replaced with actual values, as well as the period, which is the waiting period the tests take before executing, and the repeats, so how often these data points are tested are put into your service. Adding value looks like the image below. Now we get to creating our unit tests. As I've said, we have some templates for this. They're supposed to reduce the work, so there is an example image of how test sync test would look like. And here we have just a part of the file. This is not the complete file, but the relevant part. So we have the class testing test. You have the private testing service we will use, because we want to use our service. We need to instantiate it at some point. And then we have an example test written in there. Here we firstly create a new data point. We set the values of this data point, and then we feed it into the service in the process output method, as this is the method the platform will call when actually making our sync process something. So this is the one we want to test. If there's some return data or some values you want to validate, then you can and should add assert statements. An example would be assert true, in which you can put in a Boolean or a Boolean condition that will be tested if true, and it has to be true. There's also something like assert false, so the condition has to be false to pass the test. The data can be taken either from a data test file. As I've explained how you edit them, you would need to read them in. This is not prepared for the Java files, as you can just take any data. For the Python test, however, this is already prepared. We can see this on the current screen. We have open resources test data py service JSON, which will grab our file itself. We read the JSON, so it needs to be correct JSON to work. Then we only need to create our new instance of our input data we want to feed in. You can ignore the OS change dir. This is just meant to make this test run smoothly. It's needed as our Python files are quite distributed and not directly runnable without any tweaks as tests. Lastly, we need to create our service, in this case a Py service, and then also call the process new input for this. You would need to pass your test data in this, and in the end also you could change this assert true. This is just in the generation, so that it can be seen this is supposed to have asserts. You would need to find a reasonable Boolean expression that confirms your functionality. How do I run these tests? So first of all, your project needs to be imported as a separate project beside your impl model, which is a given project. And you can run single Java JUnit tests, like testing test, by just using Eclipse and telling it to execute as JUnit. This might fail. If you do have a fail with this, confirm that the execution is using JUnit 4. There are some issues with JUnit 5. But you can also run all tests by running the all test Java. You can run a single Python test by using a command mvn test -dpython test and then adding the name of the test. Later we will see some examples for this, but usually the Python test is called pytest when created. You can run all unit tests, Java as well as Python, by just running mvn test. Also, if you don't want to do the testing separately, you can just try to run mvn install and the tests will also be ran there. If you're running into problems with this, this might just take a bit more time because there is a bit more involved in the install command than just the test command. What is the output we can expect? Here we have running the mvn test, or the two Java tests. Here, marked with blue arrows, we can see the test sync and the test source test. This is the name of the test files as they were generated for this configuration. This is what you're looking for. The command line might be quite full with output, but this is what you're looking for to confirm your tests are running correctly. How do you utilize generated tests now? As I've mentioned, those are made to confirm functionality in the context of a platform and are readily available after installing. They are only possible after the application is built, thus unit testing is still valuable. Each service that's taking data as input has its own JSON template file as shown, and you need to edit these as shown before. These tests are run via mvn exec java and then the service test name. These can be read from the POM file in your imported template project. Here are some examples. Py service test and sync test would be two of, in this example, 3 tests. These will be generated as seen in this screenshot. There is nothing you need to edit about these to get them to work. Testing the whole app before deployment to the platform is the next and basically last testing step. So you need to add your bin jar to the execution of app in the template project. App is found with the other tests, and the test is just called app, so you should be able to spot it. The location of the needed file relative to your model. After installing your templates, you can find the bin jar at this location. On the bottom you can now see where you need to put, for example, the path I've shown on the screen. This path assumes that your impl model is on the same directory level, meaning right beside your imported template project. If this is not true for you, you need to edit it accordingly, for example, going up another layer with another // in front of it. If you've put this into the right place, you can then execute the test with mvn exec java add app, which should then run this test. What does this look like if we try it? First, let's look at the code we want to test in this moment. We have a pretty simple sync process here. So process new output is our method that receives the data on our sync service, and new output is our data interface. All our sync is doing is printing output and then the result value of the data. How does this look like on our console? If we look at this, in the output we have multiple things we can see. We have first test data sync test data unit, which just says what we input. So new output is a new output input with a result of 3.0. Then we have received in sync, which is derived from us defining in the IVML, like you should have seen if you're watching this video, trace kind sysout for the sync service. And below that we have output 3.0, which is our system out, which we can observe here. This is basically what you want to be looking for. If your service is actually working, you should see some kind of output like this. And if it's not working, you might either see nothing or exceptions. You want to look out especially for exceptions, because if you have no output in it and no tracing defined, you might as well see nothing. So what should you take away from this? How to write your own unit tests for Python and for Java, how to run your own user tests separately or in group, how to use generated tests to confirm the functionality before actually deploying something, and how to use the generated test for the whole app to really make sure that the deployment will work out. The last thing you now need to look at is how to actually deploy the application to the platform.